How does a tubeless tire work? In the event of a puncture, the blue car survives and pulls over safely, while the red car ends up in a fatal accident. To understand why this occurs, we need to examine the tires. The red car has traditional tube tires, whereas the blue car is equipped with tubeless tires. The difference in outcome between these two scenarios can be traced back to the fundamental design of the tires. The role of tubed versus tubeless tires. The crucial difference between tubed and tubeless tires becomes evident when considering a puncture. Tube tires consist of an inner tube, which is impermeable and designed to hold air. This tube is inserted inside the tire, providing a simple yet effective way to contain air pressure and prevent leaks through the porous rubber of the tire itself. However, a significant drawback of this design is that if a nail or sharp object punctures the tube, air can escape rapidly, leading to a sudden deflation of the tire. Let's delve deeper into this concept. In a tubed tire, when the tire is inflated, air is actually filled into the inner tube rather than the tire itself. The rubber of the tire is permeable to air because it undergoes chemical processing to achieve the desired strength. As a result, if air were filled directly into the tire, it would leak out through the small pores in the material. The solution to this issue is to enclose the air in an impermeable rubber tube inside the tire. This tube retains the air effectively, but if punctured, the air leaks out quickly and uncontrollably, causing the tire to flatten almost instantly. An additional design consideration is the valve placement. There are two options. The valve can either be attached to the rim or left loose. When the valve is loose, air escaping from a puncture can quickly rush out through the valve hole, leading to a rapid deflation of the tire. However, fixing the valve to the rim traps the air between the tube and the tire, slowing the deflation process. This might seem advantageous at first glance, but it introduces a significant risk. If high-pressure air is trapped and cannot escape quickly, it can cause the tire to burst violently. Therefore, in the design of tubed tires, engineers often leave the valve unattached to allow for the sudden escape of air, thereby preventing a potentially catastrophic explosion of the tire. Additionally, to ensure the tire remains on the rim during sharp turns, metallic beads are inserted inside the tire. However, if the tire flattens suddenly, its radius decreases, leading to a differential action where the car might veer uncontrollably, causing a severe accident. Now, let's explore how tubeless tires overcome such fatal accidents through an interesting analogy involving a sticky-taped balloon. When you puncture a regular balloon, the compressed air inside it rushes out rapidly through the small puncture, expanding the hole and causing the balloon to burst. However, if you wrap a sticky tape around the balloon and then puncture it, the air leaks out slowly through the puncture without causing the balloon to explode. The sticky tape prevents the puncture from expanding, allowing only a slow and controlled escape of air. This concept forms the basis of tubeless tire technology. In a tubeless tire, instead of an inner tube, the tire itself is designed to be impermeable, much like the balloon. To support the structure and prevent sudden deflation, engineers use a tire with a tightly glued inner liner made of rubber. When a puncture occurs, the air does not escape rapidly. Instead, it leaks out slowly and steadily, significantly reducing the risk of a sudden tire failure. To understand this in more detail, consider the inflated tube inside a tubed tire. It needs structural support against sudden deflation. Instead of using sticky tape, pieces of normal tire material are glued around the tube in a tubeless design. When punctured, this material prevents a rapid escape of air, allowing it to leak out slowly, akin to the behavior observed in the sticky-taped balloon experiment. For practical implementation, the inner region of the tube is removed, and the remaining tube material is fixed to the tire arrangement and fitted to the rim. The rim has a hole to fit the valve, which is inserted from the inside portion of the rim and locks securely when pulled out. This design ensures a tight seal, effectively making the tire tubeless. The engineering of tubeless tires. The tubeless tire design requires specially designed rims to be leak-proof. If a standard rim is used, pressurized air can easily escape through gaps, leading to deflation. To address this, engineers added an additional protrusion known as a hump on the rim. This hump locks the tire onto the rim, preventing air from escaping and ensuring an airtight fit. Fitting the tire onto the rim presents a new challenge due to the less flexible nature of the tire bead. Engineers have devised an asymmetrical rim design that facilitates the fitting process. By applying force in a specific manner, the tire can be fitted securely onto the rim. The bead is allowed to stretch slightly during this process, ensuring a perfect fit. The final adjustment is made by filling the tire with compressed air, which helps seat the bead firmly against the rim. Interestingly, tubeless tires also feature a self-repairing mechanism using a latex-based sealant. This liquid sealant can effectively seal small punctures, preventing air from escaping and maintaining tire pressure. To ensure optimal performance, the latex sealant needs to be replenished every 3 to 4 months. Can a tubed tire be converted to a tubeless tire? In practice, yes, it is possible. The primary requirement is that the rim must have a hump to provide an airtight locking mechanism. With this feature, a traditional tubed tire can be modified to function as a tubeless tire, offering the advantages of slower deflation and enhanced safety. The design of tubed and tubeless tires significantly impacts vehicle safety, particularly in the event of a puncture. Tubed tires, with their rapid deflation upon puncture, pose a higher risk of accidents compared to tubeless tires, which allow for a slower and more controlled release of air. The innovative design of tubeless tires, inspired by simple experiments like the sticky-taped balloon, provides a safer alternative by preventing sudden tire failures and improving overall vehicle stability. Tubeless tires have become the preferred choice for modern vehicles due to their enhanced safety features and ability to self-repair minor punctures. By understanding the fundamental principles behind their design, we can appreciate the engineering advancements that contribute to safer and more reliable transportation. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.